go. We are now recording. I got a t squared plus 12t plus 27. This is multiplying polynomials worksheet 9-6-2. It's probably way before that, but after that.
Okay.
Keep flipping. 9-6-2. Keep flipping. Keep flipping. Flip faster. More aggressively. Flip, 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 flip. There we go. Okay.
Whatever, Friday. That's right. But that was Thursday.
That was Thursday's homework. So we're missing some homework. We're falling behind. Okay, so this is questions 15, 23, 16, 24, 17, 25, yada, 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 all the way down to 18 and 26. Questions, comments, concerns on any of these? Check your work, the homework that you all did. I hope. Yes, you are way too far. That one, yeah. Hearing nothing. Oh, wait, 23? I'll have to go way back there. Okay. Questions, comments, concerns on any of this? You got 23 wrong? Is that a statement or is that a question? Kathy, can I do it? Yeah, absolutely I can do it. So you want 23, so I'll put a... Are there any other ones people want me to take a look at? Yeah. Let's see, 23. This looks out of focus. Let's crisp that up a little bit. Okay. There's 26 to 30. Except number 22 is not done yet. I need to add something to 22. So let's go like that. And here's 22. Okay, so we want 23. Anybody else have anyone they want to see done? Going once, twice. Can I do number 20? Okay. Anybody else? 3 times. Yeah, Carmen? Number 29. Okay, so let's do those 4 questions and then we'll move on. So here we go. Number 23 looks like this. X squared minus 5, x to the 4 plus 2y. This is a binomial times a binomial, so the procedure is still going to be what we expect it to be. So the first thing I'm going to do is multiply what? X squared and x to the 4th. Okay, x squared times x to the 4th is going to give me x to the 6th. Remember, when I have the same base, I add my exponents together. That's my, if we're doing this using the device that I taught you guys last week, we're foiling. So first, and then the outside 2 means I'm going to multiply these 2 together. How am I going to do x squared times positive 2y? Except we're going to put the coefficient out front. It's going to be plus 2x squared y. Coefficient always goes out front. And now I'm going to multiply the inside 2. Negative 5 times x to the 4th is just going to be and that's going to be negative 5 times positive 2y. That's going to be plus, nope, it's going to be minus 10y. And there's nothing there that I can group. The only thing I could do is rewrite this thing in terms of a descending degree. So I'd write this thing as x squared minus 5x to the 4th plus 2x squared y minus 10y. It is, yes. Yeah, it still would be correct. At this point, I'm not going to be super picky about writing it in the correct order. Does that make sense, Agam? You forgot to include the negative, or you forgot to just do the whole second term? Gotcha. Sometimes it helps to like actually write in, like do the lines just so you can keep it all, or keep track of it all rather. Number 20, same deal here. We're gonna multiply the front two, so 2x times 4x is 8x squared, cool. And then the outside two, negative 2 times 2x is, and then 3 times 4x is plus 12x, and then 3 times negative 2 is negative 6. You just do every piece. And so then when we group this thing, we're going to get 8x squared plus 8x minus 6. Comments, questions, concerns? Nice and easy, yes? '21, same deal. 2x times 4x is 2x times negative 2y. Cool. Now y times 4x is positive 4xy. And then y times negative 2y. Negative 2y squared. So then what happens here? Yeah, because I want a negative 4xy and a positive 4xy. So when I add those two, they're going to give me 0. Bam, 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 bam. We get 8x squared minus 2y squared, and we're done. 29. Okay, 29 and 30. I did address 30. I want to make sure that we're cool with how 30 goes. 29 is very similar. We've got that coefficient out front of the bracket. So how are we going to deal with this? The exponent first. So it's important to recognize that this squared outside, like 25 down to 30, I'll write them the exact same way. That squared outside means we're doing this. You do not distribute the exponent in. The exponent squared means I'm multiplying the base by itself. So you actually have to write it out like this so that we can multiply it properly. So what do you want to do now, Amina?
W times W, so that's W squared.
Okay.
And then W times negative Z, so negative WZ. And then negative WZ again. And then positive 4. Or no, sorry, I thought it was a 2. Positive Z squared, yeah.
And we got to remember that this whole thing is still being multiplied by that 3 out front.
3W squared, take away 6WZ, plus 3Z squared.
Fantastic. So do we all see what she did here in that last step? She did two things all combined together into one big step. The first thing she did was she took this, well, I guess I don't know what she did first. What did you do first? Did you distribute the 3 in, or did you combine these middle term first?
I combined them.
Okay. So if I've got negative WZ minus WZ, that's going to be minus 2WZ. And then when we distribute the 3 in, the 3 multiplies to the W squared. Then the 3 is going to multiply that negative 2WZ, making it negative 6WZ. And then 3 is going to multiply onto the Z squared, giving us plus 3Z squared. Comments, questions, concerns? You cool with number 29? Kind of, sort of? Okay. If you did not have a chance to look at this homework, I would strongly encourage you to take the time to look at this homework. If you need more practice, if you flipped over, I showed you the other day, the next section here, especially if you were away, it's important to recognize this. Starting on this page, this is all optional extra practice. I am not going to assign this, but I have in the past had students who were like, I have no idea what the heck is going on. Can I have more practice? Yes, here it is. There's lots of it. So if you flip here, you take a look at optional extra practice, and then it goes all the way up to question number 24, and then you'll see this. I want y'all to flip to this page. Because this idea of foiling can be extended. And this is how we're going to start class today. So we foiled with, and foiling was, we call it foiling, but really it's just distribution of one binomial into another binomial. This works with every size polynomial. It just gets messy really quickly here. Well, all you've got to do, and it doesn't make, calling it foiling doesn't make sense as you go beyond a binomial times a binomial, because to foil something literally meant multiply the first term, the outside term, the inside term, the last term. But if you look at this, there's first terms, then there's last terms, but then you've got this middle term here. So to call it, to say that we're foiling here is technically incorrect. But if I call something foiling, what you need to understand is that we're just distributing every term from the polynomial out front into the polynomial on the inside, and then everything else kind of follows the same way it did before. So if I have something that looks like this, ax plus b, and I just, instead of putting numbers here, I just put a and b, and then d, e, and f. All you need to see here is that every term from the first polynomial gets distributed into, bless you, the second polynomial. And then the second term on the first polynomial gets distributed everywhere into that second polynomial. So I made a mistake here. Where's my mistake in this first line? Yes, Kyla, did you find it? Angel found it? Did one of the two of you find it? Yes, this should be x cubed here. So make a change to that if you could, please. You know what? That doesn't look like a 3. I'll just scribble it out and put a 3. And so then I gave you a concrete example. I said, well, what if I have just x plus 2, and then I times it by x squared plus 3x plus 4? I just have to make sure that every term gets multiplied everywhere else. There are other classes, they call these things flying arrows. I think it's silly. I don't like terms like this. I just want to teach my students to do the math. I don't necessarily want to have pithy terms to help us remember this. You're distributing. You're distributing every term from the first to the second, and to draw these lines just helps you keep track of what you've distributed. So x times x squared, x times 3x, x times 4. 2 times x squared, 2 times 3x, 2 times 4. And then you group what you can group, and you leave what you have to leave. There is no other x cubed term, so that's just going to come down here. I've got 2 x squared terms, so I'm going to combine those. 3x squared and 2x squared is 5x squared. And then I've got 2x terms, and then I have only one constant, and then we're done. It's the same with trinomials. It's just a lot more work. We have to make sure we distribute every term onto every term, and you get things that look big and nasty and look like this. The procedure is the same, though, and so even though it gets a lot more convoluted, as long as you keep track of the work that you've done, there's no reason why you couldn't do this easily as well. So, are there any questions before I get you guys to practice a bunch of this stuff? Yes, Angel, you are 100% correct. It's ugly. 100%. But nobody said math had to be attractive all the time. Yes, Danny. Hold on, guys. There's a question.
So, like when you have in your brackets, when you have the thing that you're distributing, it's like a 3, and you distribute it between 2 and 6, but you have the x plus 2, you're distributing the x and the 2 like that.
2x, you mean?
Or,
oh, here.
Yeah, there.
Okay.
So, is that, no, it's not though, but is it like taking that whole thing and like doing x plus 2 multiplied by x squared
is it just to take that whole thing, or is there a reason besides making it more like simple and like to take the 2 and distribute it to all those ones and then the x? I don't know if that's making any sense. Like,
So here's what you're asking, and I'm pretty sure.
is it the same thing as having one? It's not though, but
No, it is actually.
it is.
It is.
Okay.
So here's what Danny's asking. I won't write it on the page because it'll get
Yeah.
even more gross, I think. But what you're asking, Danny, is if I do x plus 2, and my question was x squared plus 3x plus 4,
Yeah.
could I not just take this entire thing and
Yeah.
distribute it in?
Is that what's
You
happening?
absolutely could. This would give you x squared bracket x plus 2 plus 3x bracket x plus 2 plus 4 bracket x plus 2. You're distributing that whole thing everywhere. And then you have to distribute,
Okay.
and you get x cubed plus 2x squared plus 3x cubed plus 6x plus 4x plus 8. And you'd say, okay, well, I've got that, and I've got,
And then you
that's a
group?
squared. Yeah. So it's just going to be x cubed, and then you group these two, giving you plus 5x squared. You group those two, plus 10x plus 8. And if I'm not mistaken, you should get the exact same thing we did before.
Yeah. Okay.
But the reason I don't teach it like that is because it's just,
And it'd be easier for the shorter, like just a binomial.
yeah, but I mean, you get the same,
Yeah,
you
like
get the
a-
same result. Yeah.
Okay.
Yeah, there's no reason why you couldn't.
Is that,
Angel made a comment about how what we had before was ugly. I think that's uglier.
yeah, but I can see it, like I'm like.
But
oh,
if that
makes
helps you
sense.
understand it better, that's what's happening here.
Okay. That'd just be a lot harder to do with the binomial.
It just gets, yeah, it just gets nastier.
Okay.
It's more involved. Like, and so there's always a trade-out. Like, I don't know if I've said this to you guys before, but I've said it to my physics students. This is something I want the front corner to hear. Angel and crew. This is something I've told my physics students. This is something I'll tell you guys as well. There is always a trade-off between the amount of work something takes and how hard that work is in mathematics. You can make the work itself simpler, but there will always be more of it. If you want to make things more elegant and do less work, it will be conceptually more difficult. And so there's always a trade-off there. The same is true in physics, because physics is just applied math, which is why it shows up there first. But there is, yeah, I mean, if that's how you understand it better, that's great. But it is going to take more work to do it that way. So I try and walk the line. When I teach you guys things, the optimum, in my mind, the optimal way to teach it is one that walks that middle ground of optimal efficiency. Not too hard conceptually, but not too much rote work, without just teaching you guys shortcuts, because if you don't understand why the shortcuts work, they're useless. I don't want to. My goal is not to create people who can just do math. I want you to understand it and be able to extend it. So that's why I also don't teach shortcuts. Flip the page if you haven't already. There's 6 questions there. I'm going to give you 10 minutes to do them. On your market set, giver, try them. If you haven't already discovered it, the answers are on the next page. Right there. And they are questions 25 to 30, so this section right here. So if you didn't do any of the distribution homework, you're going to get trial by fire here now. So these questions at the top where it says warm up, yeah, we're going to skip those because you've already had a chance to warm up today. And I want you to jump down to here. What we're going to look at today is, well, the rest of today is look at how you actually divide these things properly. So if you haven't finished those previous 6, that'll be part of your homework. Otherwise, let's move on here. So when we're dividing things, and I think this is the only... Yeah, this is the only section that only kind of division we're going to do. There will be more division next year in grade 10. You can divide bigger terms by like, or larger polynomials by larger polynomials. But for the sake of your sanity and mine this year, we're just not going to do that. I'll save that for grade 10. But what we are going to look at is, what does it mean to divide a polynomial by a monomial? And I think this should be relatively straightforward for you guys, because if you manage to handle it in the exponent section, this will be okay. So if I have something like this, 3b cubed minus 6b squared plus 9b over 3b. If I have a fraction that looks like that, how do I deal with that thing? Danny?
Would you distribute it to all of them? Like divide 3b squared by 3b and 6b, or sorry, 3b cubed. And like just like.
Yeah, that's exactly what you do.
Okay.
Because if you have an expression in the numerator with multiple terms over a single denominator, this is the same thing as writing it like this. 3b cubed over 3b minus 6b squared over 3b plus 9b over 3b. It's exactly the same. Because if you look at what I've got here now, if I were to recombine this thing, because they already all have a common denominator, I could just add and subtract the numerators and then write it over a single denominator. We're just going backwards. We're undoing what we would have done in the past. And then how would I handle each one of these? If you think back to if I gave you just this, what would you do? Jacob. So I'd simplify the coefficients. Yeah, 3 by 3 would be 1.
And then you divide b2 by b to the power of 1, and then minus the exponent.
Right, so if there's no exponent written here, we assume the exponent to be a 1. And when I divide the same bases, I do what with the exponents? I subtract them. And it's always top minus bottom. So if I've got the 3 divided by 3, that's just going to give me 1. And then, as Akam already said, b cubed divided by b to the 1 is going to be b to the 3 minus 1, which is just b squared. My next minus, what's this guy going to be? Minus 2b, good. 6 divided by 3 is 2. B squared divided by b is just b, plus it's going to be, I've heard a few things, but it's going to be just 3. Because b divided by b is b to the 0, which is just 1.
Right, okay.
And then it will be, so 9 divided by 3 is 3. So then, and then 3 times 1 is just 3. Relatively straightforward, yes? Okay.
Could you group that more, or no?
Could I do which? Could I group it more? No.
Negative 2b cubed?
No. Because you can only add or subtract like terms, and terms are defined to be like if they have the exact same variables to the exact same exponents.
Okay.
These are not like terms. Okay, so let's slide it over and do a slightly more gross example. And fill in this blank right here, so, which you've already said. We divide each term of the polynomial by the monomial. Remember, exponent laws, when dividing powers of the same base, you have already said it, subtract exponents. So, if I've got this thing, 36x cubed y plus 18xy squared plus 9xy over 27xy, how do we handle something like this? The procedure is exactly the same. You slow it down and march it through. I believe the vast majority of you, if not all of you, the only people who can't do it are the ones who are away today, not at the lesson. I believe all of you present can do this. And just simplify each variable in each term.
Since for the n1,
Yep.
yeah, I guess we can rewrite it.
First, yep.
But after you do that, then I have a question.
Okay, let's rewrite it. So, and I would, at least at the beginning, to get a handle on this, I would encourage you to do this first step. Eventually, you guys will get fast enough. You'll see what's going on here. You might not have to write this first step, and that's fine. But for the beginning of this, please humor me and do this. To make everyone really sure you guys know what you're doing. what we're going to do is we're going to rewrite the numerator over every term in the numerator over that denominator.
So,
And now Dan's got a question.
for the last, like 9xy divided by 27xy, since 9, I mean, it could be divided by 27, but it'd be really ugly. Like, but you can divide 27 by 9, so would you just make it negative 3x squared y squared? No?
Let's talk it through. We're going to talk through each term. Okay, so we're going to do the same thing Akam suggested before. I'm going to divide my coefficients in every term, and I'm going to divide my variables in every term. Can I divide 36 and 27 cleanly? No, I can't. So if I can't divide it cleanly, 36 over 27, what I'm going to do is I'm going to reduce or simplify that fraction. Absolutely. What can I pull out of 36 and 27? That doesn't answer my question, Carolyn. What can I pull out of 36 and 27? I can divide both of them by 9. If I divide both of them by 9, 36 divided by 9 is 27 divided by 9 is, so I get what Carolyn said, I'm going to get 4/3. Now, I'm going to divide x cubed by x. It's going to be x squared, yeah. And I'm going to divide y by y, leaving me with?
No, you have y. Wait, I wrote down squared. No, I'm sorry.
Right, it's going to be y to the 0, which is just 1. So I don't have to write 1 because multiplying by 1 doesn't change anything. Plus, I got 18 over 27. What's that going to reduce to? 2 over 3, good. And then what's going to happen over here with my x's, y's, and y squareds and all that grossness going on over here in the variables? Carolyn?
X, and you can like divide them to x over 0. You don't need to divide. And then the y.
Right.
Y squared and y squared over 1 is just y.
Cool. So that thing's going to reduce down to just y. We cool with why that is? Okay. And then my last term, and that's it. Good. So I get this. I get 4/3 x squared plus 2/3 y plus 1/3. Love it. Comments, questions, concerns? Okay. Do we need to do the practice, or should I just launch you straight into party time? Take a look at these 3 questions, and are there any one that you guys want to see done here?
I just want to know, is number 3 just 4y squared, like the whole thing just divided by 4, but does it matter that there's brackets? Because technically division, there's brackets on both of things.
Okay, so yes, for whatever reason,
That's just that, okay.
it's written gross, but this does mean the same thing. It's this whole thing divided by this denominator, divided by this denominator. But the procedure is exactly the same.
Okay.
I can't remember why I wrote it like that. I shouldn't have.
But it's tricky.
But it's the same thing.
So, now we know.
It's good to see notationally
Yeah.
what's happening here, but this means the same thing. Are there any one of these 4 anyone wants to see me do? If not, then I want you to take a couple minutes and I want you to do each one of these.
Okay.
And then I will, here's what you're looking for.
Maybe. Yeah.
Try those 4. Presley, you want to rewrite example 2 into 1/3 bracket at 4x squared plus 2y plus 1? Is that what you're doing?
I think so. Something like that. Like bring it back just all over. Yeah, and then
We're going to do that in a sec.
that's my.
There's language that I...
Yeah.
Short answer is yeah, it's kind of where we're going. But we're going to do that plus a whole bunch of other stuff. Take a look at those first 4. This is what you're looking for.
Okay.
We'll give you a couple minutes. Comments, questions, concerns about any of those? Did you try these ones, Carmen? Okay. We're good? No? Okay. Take a couple more minutes. Love it. Believe it or not, we're actually almost done this unit. There's only 2 lessons left. No, there's not going to be a quiz this unit. I'm not going to give you a quiz on polynomials. We're just going to... Because it's so short. I've only got 2 lessons left. Okay, we're cool with these. Does anyone want to see any of these 4? Going once? Going twice? Thrice? Let's do number 4. Boom. Okay, so here's number 4. Again, just like before, what we want to do, don't write it like this. This is a gross way to write it. So what we're going to do is we're going to rewrite it as every term over the denominator. And then we're just going to reduce everywhere. Can I reduce 3 over 2? No, so we're just going to leave it 3 over 2. What's going to happen with my a, b divided by b here going on? B is going to cancel, leaving me with 3 over 2a minus what? 6 over 2 is 3c. Done. Love it. Nice and easy. Okay, so here's what I want you to do. I want you to flip the page. There is a technique that I am not going to make you guys do involving long division. You can ignore this for now. It's going to come back at you next year. Those, whenever you see dot, dot, dot like this, it should be ominous. Like you should feel like it should be ominous. Dot, dot, dot is always ominous. Especially when it's preceded by for now. Dot, dot, dot. It means it's going to come get you out of the dark later. You're going to be walking down a dark alley and all of a sudden, bam, long division with polynomials. Going to get you later. They should. Okay, here's what I want you to do. So we're going to make your life a little bit easier here. I think we should make your life a little bit easier. No, I purposefully tried to remove those. We're going to go like this. Yeah, I want you to do odds. 1, 3, 5, but only up to 9. And then I want you to do all of this crazy town down here. Actually, should I make you do all those? No, I'm not going to make you do all of those. I lied. Should I? You know what? We're going to do evens down here. Do odds, and then do evens. And I'm not going to give you anything else. So if you didn't finish those first 6 multiplying larger polynomials together, finish those 6. and then do odds here, evens down there. And that is everything I'm going to give you today. May the force be with y'all, and I'm happy to assist you with whatever you might need assistance with. On your market, set, go.